back to my channel. In this video, I am going to explain you about the transformer architecture. So transformers plays a very important role in the subject of large language models because they are the brains behind the LLMs. They are responsible to understand and generate the text. So it is very important for you to understand the architecture of the transformer. And in this video, I am going to explain you about the components, how the input is processed, and the very important mechanism which is self-attention mechanism, then how the refinement process happens, and at last we'll understand how the output is generated. So before getting started with this video, if you are new to this channel, then please do subscribe, and if you are already a subscriber, then please do watch whole video and hit the like button. Now let's begin. We will understand the components of a transformer architecture. So these are the components. The first thing is input. When an input is given, it will convert that input into tokens. And as the computer can't understand these tokens because they are in English, computers can't understand. The only thing it can understand is numbers. So the transformer tries to convert these tokens into numbers, and that process is known as embeddings. Let's also understand how a numbering is given. There are different mathematical calculations behind how the numberings are given, but let's say your text is having these two words: happy, joyful, engine. Your text, whatever the text you have given to the transformer model, that text is having this three words, and now that text is divided into tokens. Now happy is one token, joyful is another token, and engine is another token. As I discussed earlier, that computers can't understand the text, so it has to be converted into numbers. Now happy and joyful are having some similar meaning. So what the model will do is it will give a number which is close. Let's say for happy it has given some 0.6, and for this joyful also it will give a number close to happy, so 0.5. Now this engine is far related to this both words, so it is having some number as 0.1. So this is how the numbering is given. Now internally the transformer will form clusters. The tokens which are having close numbers, they are treated as one cluster like this. In this cluster we will be having two words, that is happy and joyful, and there is this another cluster, it will be storing engine. So this is how the embeddings happen. Now after the embedding process is done, the positional encoding, what it will do is, see, we have converted every token into numbers, but the model does not know the order, the word order of that sentence. So what it will do, it will add the position also for that words. For each and every word it will add the positions in order to remember the word order. Now here encoder is optional, so whatever the decoder does, the encoder does the same, but it is only used in the older models, not in right now. Whatever the GPTs we are using, it is not there, so we can skip this. But decoder, we'll discuss about decoder. See, decoder, in decoder we will be having these three things. First one is self-attention mechanism and feed forward network, and then how the output is generated. All this is done by the decoder itself. So now let's understand what is self-attention. So this is the most important part. We have converted everything into numbers and we have marked the text with the positional encoding also, but that doesn't mean the model has understood the intended meaning in that text. So the self-attention layer is responsible for the model to get understanding of the text. So in the self-attention, the model first tries to understand how each word is related to all other words. So this is how a transformer can understand the context so well. Multi-head attention is also same as self-attention only, but in multi-head attention there are multiple attention heads. That means suppose in the first head it will understand what is the subject, in the second head it will understand what is the object, in the third head it will understand the intent, and in fourth head it will understand the topic, in the fifth head it will understand the target. So by this the model gives the deep understanding of that sentence. Now in the feed forward layer, so the self attention will happen in feed forward network only. So there are some layers, so for every layer there is self attention happen. So in the first layer if it understands some grammar, so that input is passed down to the second layer, sorry, that output is passed down to the second layer as input. In the second layer it will understand the emotion, and it will generate you some output, and that output is passed to the another layer. So as passing through every layer, the model will get the deep understanding, and at last it will generate you the output. See, when the model takes the input, it will take the input all at once, but when it is generating the output, it will generate word by word. Okay, now let's understand how the input process is happening. So the first, tokenization. You already know tokenization is nothing but you are breaking the input sentence into tokens, and that tokens are converted to numbers. After converting into numbers, you have the model has to know about the word order also. So the positional encoding is given. So this is how the input is processed into it. Now, because of the self attention mechanism, the model will try to understand the deep meaning of that sentence. It will look how one word is related to all other words in the sentence, and it will builds a deep meaning which is essential for context understanding. So multi-head attention is also same as self attention only, but here you will be having multiple heads. So in one layer it will be understanding the subject, in the other head it will understanding the object, and in the third it will understand the intent. So this is how a deeper understanding is got for that transformer model. Now, as I said, so for every layer the refinement is happening. That means the model will, for every layer the model is improving its understanding. In the first layer it will understand how the sentence is formed. In the second layer it will understand what it is telling about that sentence, what I have to do. All these things the model will understand. So that is happened by this feed forward network only. And then see, this feed forward network will have many layers. It depends on the model. See, some models will be having around C12 layers, and some models there will be having 96 stack layers also, more than 100 layers also. It depends on the model. If there are more layers, that means the refinement is good. That means it will generate you the accurate output. Now, how the output is generated? So whatever the understanding is done by the model, it is passed on to the decoder, and it will apply the masked self attention rule. That means it will generate the output word by word. Instead of generating all at once, it will generate word by word, and that is how the output is generated. And see, this whole process is happened in milliseconds. This whole process is happened in milliseconds. Right. Now, so this is about the large language model. Yeah, thank you for watching till end. I think if you have got a clear understanding, give me thumbs up. And if you have any suggestions, then please do it in the comment section. And if you want to join our Telegram channel, please join. I will give it in the description and also my Instagram. Thank you. Bye.